Hello everyone, Calorimetry 2. Today we talk about a constant volume calorimetry and constant pressure. Let's start with a constant volume. In isolated system, we know that is no heat enters or leaves the system throughout the process. The heat change of the system, Q system, should be 0. And we can write Q system is equal Q or heat of calorimetry plus heat of reaction, and this should be 0. So Q calorimetry is equal minus Q reaction. Also, Q calorimetry is equal C calorimetry quantity delta T. The quantity of C calorimetry is calibrated by burning a substance with a currently known heat of combustion. Let's solve an example. A quantity of 1.435 gram of naphthalene, and this is the molecular formula. Substance used in mouth repellents was burned on the constant volume pump calorimetry. Consequently, the temperature of the water rose from 20 to 25. So this is the final temperature, this is the initial temperature. If the heat capacity, let's mean C, is equal 10.17, calculate the heat of combustion Q of naphthalene, find the molar mass of combustion. طيب. The heat absorbed by the pump and water is equal to the product of the heat capacity and the temperature change. Q calorimetry is equal heat capacity for calorimetry delta T. This is from a question. It's 10.17 times 25.95 minus 20.28, and it's equal 57.66 kilojoule. This is the Q calorimetry. Q reaction is minus Q calorimetry. That means it's minus 75.66 kilojoule. We should calculate the molar heat of combustion. It's equal Q reaction over number of moles. And the number of moles for naphthalene, it's a mass to the molar mass, it's equal 128.2. The number of mole here is equal 0.01 mole. We substitute here minus 5766 on 0.11, and the answer is 5.1 0.51 times 10 to the power 3, and don't forget the minus, kilojoule per mole. Let's now talk about the constant pressure. And I prefer to solve this problem a lead PP pellet having a mass at temperature was placed in a constant pressure calorimetry of negligible heat capacity containing 100 ml of water. The water temperature rose from 22 to 23. What is specific heat of the lead pellet? So here, this is initial and this is final. We have a lead pellet and it has mass. It's 26.47 with 89.98 Celsius degree. And also here we have 100 gram of water or 100 ml of water. It's the same because the density of water is 1. So we can write 100 gram of H2O or 100 ml. After that we will convert it to gram. The temperature here is 22.5 Celsius degree. And after that, here, the pellet is here, with a temperature or a final temperature 23.17 Celsius degree. So, to solve this problem, we know the masses of water and the lead pellet as well, the initial and final temperature. Assuming no heat is lost to the surrounding, we can equal the heat lost by the lead pellet to heat gained by the water. Knowing the specific heat of water, we can then calculate the specific heat of lead. So, we said Q lead or heat of lead plus heat of water is 0. So the heat of lead equal minus heat of H2O. Okay. Heat of H2O equal what? Equal mass specific heat delta T, where the mass is 100. And why it's 100? It's 100 ml, and the density of water is 1, so the mass is equal the volume with 4.184. This is the specific heat of water from a table, and temperature 23.17 minus 22.5. This equal 280.3 joule. Then the QPB equal minus 280.3 joule. After that, QPB, the heat, is equal mass, because we know the mass of pellet, S, we need to calculate it, delta T, we know it. Mass And we also calculate the QPB. So here it's minus 280.3 equal what? 26, the mass here. Yes, 26.47 times S. We need to calculate it. Times delta T, it's 23.17 minus this temperature, because it's for lead. From this equation, S is equal 0.15 joule gram to Celsius. Okay. Let's solve another example, and this is the last example. A quantity of 100 ml of 0.5 molar HCl was mixed with 100 ml of 0.5 molar also NaOH at a constant pressure of negligible heat capacity. The final temperature of the mixed solution, the initial temperature of the HCl and NaOH solution was the same of 22.5, and the final is 25.8. Calculate the heat change neutralization reaction molar mass and assume that the densities and specific heats of the solution are the same of water 1, and specific heat it's 4.184. طيب. Assuming no heat is lost to the surrounding. So Q reaction, as we know, equal minus Q solution. Because the density of solution is 1, the mass of 100 gram is also 1. So Q solution is equal the mass for HCl and NaOH. So here is 100 and also here 100. So 100 plus 100, this is the mass, times the specific heat, because it's the same to the water from question. And we have initial and final temperature, it's 25.86 minus 22.5 is equal 2.81 times 10 to the power 3 joule, converted to kilojoule, so it's 2.81 kilojoule. Then Q reaction is equal minus Q solution, so it's equal minus 2.81 kilojoule. This is the heat of reaction. And from the molarities given, the number of moles of both HCl and NaOH in 100 ml of solution is molarity, number of mole on volume. So here it's 0.5 and here it's 0.5 as well, 100 ml and 100 ml. So it's the same. It's 0.5 mole on 100 ml. So we convert it to liter, and the answer is mole. Heat of neutralization is equal Q reaction over N minus 2.81 over 0.05, and it's equal minus 2 kilojoule per mole. That's it. Thank you so much.